You have entered as an attendee in listen-only mode.
Okay, thank you. Okay, let's wait for a few minutes. Let us join, then we're going to start. Okay, guys, so let's start with today's session. So first, we are going to revise what you learned yesterday. So we have started with our new module, the networking part, and inside that first we discussed what is network, okay, and then what is IP address, the different kind of IP addresses, IPv4 and IPv6, and then we have seen what is CIDR block, how to find the range of IP inside a CIDR block. Then we have moved to Amazon VPC section, where we have seen what is VPC, what are subnets, and what are the public IPs, and like what is a CIDR block, and what are the elastic IPs. So till here we have completed. So let me take the questions, and we're going to start. Okay. So first one is okay. So just tell me the number of IP range for this particular CIDR block. Okay. So what will be the IP range? Number of IPs for this CIDR block? Calculate and tell me the number of IPs. Hmm. Yeah, very good. I'm getting a correct answer. Yes, it is 64, 2 to the power 6. So 32 minus 26 is 6. And then you have to multiply it with the power of 2. So 2 to the power 6 will come as 64 IP. So the correct answer is 64 IP. Okay. Okay, so what is the difference between IPv4 and IPv6 addresses? What is the difference between IPv4 and IPv6 address? Hmm. Chicken, I'm asking what is the difference between IPv4 and IPv6 address? Yes, you all are correct. IPv4 is a 32-bit address and IPv6 is a 128-bit address. That is the main difference. Okay, so suppose I created I created a AWS infra using VPC, and inside that I have launched a web server using a public and using a public IP address. So that public IP address is connected to my DNS name. Now each time whenever I am restarting my machine, that time public IP is getting modified. So to resolve this problem, what should I do? I am using a web server on which I advertise a public IP, which is getting changed once I will restart the server. And that server IP is attached to my DNS, suppose google.com. Now every time when I am restarting the machine, it is changing my IP. Now what I should do to resolve the issue so that I will get a same IP every time? Very good, Raghavan. I just got a correct answer from Raghavan and Nathan. Right, guys, private IP is for internal communication. Your customers cannot reach out to your application using your private IP. That is not reachable. That is for internal communication. So in this case, you're going to use your elastic IPs. So you have to request for elastic IP that you can use with your with your server. And auto assigning IP should be off. That is a half-hearted answer, Shrikant, because that's fine. If you are using that option where you are not auto assign IP to a server, that means none of the public IP will be assigned. Then too, you have to create one elastic IP to assign to your server, because one address should be needed for a machine. Otherwise, how the communication will come to the machine? Okay, so that is there. Anything else is left? I think none of the questions are left. Okay, so somebody has asked me that CIDR and subnet are same. No, these are not same. CIDR you also created for your VPC. Suppose for this example, this is your VPC CIDR. The same way you create a CIDR for your subnets as well. So both are not correct. So whoever I have asked this question, I'm not remembering the name, but both are not correct. Okay, CIDR is, with the help of CIDR you assign a range of IPs. So you can assign a range of IPs to a VPC and to your subnet. Those subnets are the subset of your VPC. That means if you are creating a CIDR for 64 IPs for a VPC, then if you are creating two subnets, then you can divide 30 to 32 IPs. That means a smaller CIDR for both subnets. That's why subnetting and CIDR is not same. Okay, I hope it answered. And yesterday, okay, some questions from Nitin. Okay, some networking question. First of all, DHCP. It is a Nitin is it is a dynamic host configuration protocol. So with the help of DHCP, you assign your public IP to your to your machines. So automatically, when I'm saying that I am automatically assigning IPs to my subnet, to my EC2 machines, that means it works at the subnet level. So at the subnet level, the DHCP protocol, I know every layer the protocols works. So the DHCP protocol is going to take some public IPv4 address or IPv6 address, whatever you have configured. It is it is going to take that, and then it is going to assign automatically to your machine. If suppose you are using elastic IP, that means you are assigning from yourself because you have requested an IP. If I am using a auto-generated IP, if I want to assign, that internally this dynamic host configuration protocol, this protocol will come to the action. At the subnet level, it is going to assign IP to your machine. That is the first part. Second was your RPC. That is your remote procedure control. So inside the computer network, we have the client and server machine. So how the client is making a request remotely to your server, this whole process is taken with the help of RPC protocol. So there are multiple protocols at each layer of our networking system. So RPC is one of the protocol which takes care of this remote connection between the client and server machine. That is a simple definition of RPC. Now coming to the third part, that is a NetBIOS. So it is Network Basic Input Output System. This is the abbreviation of NetBIOS. And with the help of NetBIOS, this works as your network layer. That is your layer number 4. Inside the OSI model, it works at layer number 4, specifically at the like where we use this TCP UDP model. So what is the use of this? Okay, like inside the network layer, it helps us to bind both machines, the sender and the receiver machine. So how it is binding? Because at this layer, I told you yesterday also, when we are routing something, the router which is working at the network layer knows which is the IP of your sender, which is the IP of the, like of your receiver. So that's why the connection is bound, because with the help of the net BIOS, we know from the sender machine, which receiver machine is going to get this file. Or in the other way, I would say, from the sender machine, like where the sender machine is going to send the file. So this connection between different computers takes place, the bonding between the two computers has taken care with the help of this net BIOS, which works at the, the network layer, which is your layer number 4 at OSI model. Okay. So I think all the pending questions are done, Nitin. Is it clear? Okay. Yeah, thank you. So guys, before starting, okay, my issue for this lab is fixed, okay. So today I will tell you how to access the lab, and who like I believe you would have completed the first lab. So how many completed, guys, from themselves? Anyone? Have you guys tried the lab? If you have tried, please put your yes or no. If you're not tried also, it's not a problem, because today I'm going to tell you the procedure how to access the lab. So today also you will get a time, and tomorrow for sure we're going to discuss this lab, guys. Okay, let me check the response. Okay, no problem. I think very few. Okay, Raghavendra have tried. How many have tried? Okay, I think few of you guys have tried. No problem. Please try, guys. Please try. Okay. Today I'll tell you how to access the lab, and please try to complete today. If not, then tomorrow we're going to discuss. But please at least try. It will help you a lot. Okay, so how to access the lab? First, you have to reach out to the module and then click on the lab. Once you will click on the lab, it will take you to this lab page. So first, when you're trying to access the lab, you have to click on agreement. Okay, it will ask you to agree some kind of a agreement between you and this website. So just agree and click on continue. Then you will be navigated to this kind of a page. Here you will see on the left side, you will see the instruction. So these are the instructions. So if you would have checked out the instruction also, here also it is giving you all the instruction how to access the lab. Access your lab, okay, the AWS management console. So apart from that, whatever task we have to do, here everything is explained here in a guided way. So based on that, you can complete the lab. These are the guided lab. Inside our architecture part, we will also have the challenging lab, where you won't find the guidance. You will only find that it will ask you to complete the task, and then with a minimal guidance, and you have to complete the task from your knowledge. With the help of your knowledge, here you will get all the all the tasks. So go to your task and complete the lab. So how to start the lab? Just click on start the lab. So it is going to take few minutes, maybe 2 to 5 minutes is going to take, and it will open a small pop-up window. It's going to open now. So in that window, like this is the window. So currently it is in creation. So once this lab status is changed to created, that means the lab has been set up, because internally for this lab, it is going to create all the resources for your lab, okay, as a part of the lab. So it will take few minutes. Once it is done, then the status will be changed to created. So it will take some time, okay. We have to wait for that. Once it is done, then you can cross this and you can click on AWS. So let's wait for some time, okay. Can you do show IAM, sir? Yeah, we will do, Mani. Tomorrow we will do. We will do all the labs. I will do, guys. I will do all the labs of your, all the guided labs of your, what is this, this cloud foundation. And once we will move to the architecting, then I think you will get the confidence to complete the guided lab. Then I will do all the challenging lab, where the solution is not guided, where we have to complete the solution from our end. So I'm going to complete those, and by the time you will already have a hands-on on multiple guided labs, so you can take care of the guided labs, because it will have the instructions which you can read and you can complete it out. Okay, but here on this foundation part, I'm going to complete all the guided labs. So don't worry, Mani, but please try this solution from here. I'm just showing you how to access the lab. Okay, so if you are facing an issue in accessing, you can do these steps to access the lab. It is pretty much straightforward, nothing much. Okay, so you have to wait for some time. Okay, take some time, maybe around 5 minutes to create the lab for you guys. Okay. Okay, so by the time this gets created, let's don't waste the time and move to our concepts. Okay, so once it will be created, I will jump back to the session and we are going to check the further step to access the lab. Okay, so let's start today's session. So Elastic now, till yesterday we have completed till here, guys. Okay, so we have completed just a minute. We have completed this, the public IPv4 and Elastic IP addresses we have completed. Now, okay, one more question I will ask you. So suppose, guys, I am rebooting a machine. I am rebooting a EC2 server. Will I will lose a private, public IP? If I am rebooting a machine, will I lose my public IP? The current public IP? Yeah, very good. Please don't unmute, guys. Please don't unmute. I'm getting a disturbance. You can put your answer. Very good. Ashmita, I'm asking about rebooting, not restarting, Ashmita. That's why I told you the difference between restarting and rebooting. Okay, so in rebooting, we are not going to lose our public IP, it will be same. If I am restarting the machine, that time, my public IP will be modified. Okay, yes, the same thing I expect. Somebody has, guys, please mute yourself, I'm getting a lot of disturbance. Otherwise, I have to mute you from here. Please. Okay. Yeah. So now let's start with what is ENI. So like yesterday I've told you that like when you're creating a CRI block, it is giving you a pool of IPs, the IP range, and all of the private IPs which will be attached to a machine which you're going to launch inside a public, like inside any subnet. Okay. Suppose there was a range of 10.0.0.0 to 10.0.0.0.7. So if you are launching any machine inside that pubnet, it's going to take that particular, like a single IP from that particular IP range. So now, how that private IP is getting attached to that particular EC2 machine? It is done with the help of Elastic Network Interface. So Elastic Network Interface is a virtual network interface that you can attach to instance. So whenever it is getting attached to instance, that means it is providing a private IP. That is a functionality. ENI attach a private IP. So whenever, like you will find, suppose, like by default, whenever any EC2 machine is created, our default ENI is always attached. Because, we are getting one private IP attached. It is done because of the default ENI. So automatically, at the time of your machine creation, automatically it is going to pull one ENI, and that ENI will contain one private IP from the IP range of a subnet. From there, it's going to pick one IP, it's going to attach to your EC2 machine. That's how your EC2 machine gets a IP through this ENI. So you can also attach multiple private IPs to a single machine. That is also possible. So that means, there will be, first of all, I've told you, there's a default ENI that will be there. So you cannot delete that default ENI. You cannot detach that default ENI. But you can attach more ENI to a single EC2 machine. So that means it is telling you can attach it to an instance. You can attach this ENI to an instance. So when you are attaching an ENI to an instance, so it is going to attach another IP to your machine. What is that IP? Private IP. The second statement is telling detach from the instance and attach to another instance to redirect network traffic. So now, if I will tell you that can you detach the default ENI? No, we cannot. We cannot detach that. If suppose you are attaching, like we want to attach two private IPs to a single EC2 machine. So one you will already get when you are at the time of EC2 creation with the help of default network interface, Elastic interface. Now suppose you want to attach another, this private IP, then you will create another ENI and then attach it to your EC2 machine. Then you will see two IPs will be present for your, two private IPs will be present for your server, for your EC2 machine. So that additional IP you can detach also. If you are attaching that additional IP, you also have a power to detach that additional IP and attach it to another machine. But you cannot detach the default ENI. That is not possible. whatever additional ENI you are attaching, which is going to give you an additional private IP, which will be attached to your machine, that you can detach and you can attach to, then you can attach it to another machine. Okay. So its attributes follows when attached to a new instance. So whatever, a private IP configuration would be there, that will be followed to a new instance also. Each instance in your VPC has a default ENI that is assigned to that assigns a private IP address from the IP address range of your VPC. The same thing I've told you. So look at this. This is the symbol of ENI, guys, the purple one, like a bus kind of a shape. So with the help of, what is the purpose of ENI? It helps you to assign a private IP to your EC2 machine. And from where it is going to take the IP? It is going to take the IP from the CIDR block of your subnet. Because inside the subnet only you are going to define the resources. So that is the use of ENI. Let me check if this is created. Okay. So let's just jump back and complete this thing, and then we're going to concentrate on the topic. So now look at this. The lab status is ready, guys. So now you have to just cross here and now click on AWS. Now look at this. This is how you can access your lab. Now look at this. You will get, this is the user, and you have to make sure you have to work inside the North Virginia region only. Please don't change the region, because they have created the lab inside North Virginia. So please follow the task and you have to complete the lab, okay, inside North Virginia. All, all these labs you're going to complete inside North Virginia region only, unless it is specified to change the region. Okay. So please make sure that thing. Now, once you will complete the lab, you will perform the lab here. Once you will complete the lab, you have to just, click on, click cross here to close this AWS management console. And here you come back and click on end lab. So it will ask you, are you sure you want to end the lab? You can end the lab, click yes. And then it is going to terminate. It is going to automatically terminate all the resources which you have created. So you can just cross this. You don't have to wait here now. You can cross it and you can come back to your module and you can try another lab. So it is so simple and straightforward. Please try the lab. All the solution is guided. So just try. If you're not able to do, tomorrow I'm going to perform this. Okay. Okay guys, so this lab part is pretty long. Let's go back. So Ashwani, it helps you to assign a private IP to your, it helps you to assign a private IP to your EC2 machine. Okay Ashwani? Okay guys, so now, why we do this, okay, why we assign, in which case we assign these, multiple private IPs to a single machine. Suppose if you want to run, two applications on a single EC2 machine, that time, or suppose you want to run, you have created some distributed kind of a network and you want to run two components on a single server. So for that also, if you want that, both components will be reachable to, different IPs, then you can connect multiple ENI, because ENI will give you a private IP, and for that private IP you will have a corresponding public IP that you have to attach, because private IP is helpful for the internal communication. The public IP is helpful for the public communication. So if you have that kind of a infra where you have multiple applications on a single server, then we use ENI so that you can have multiple private IPs attached to a single machine, so that you can have multiple IP addresses also for a single machine. That is also possible with the help of ENI. Okay, so it is clear now. The main functionality is it helps you to assign a private IPv4 address to your EC2 machines, and from where it is taking those IP addresses, it's taking from the CIDR block which you have defined at the subnet level. Okay, so this you have to, this is clear. Now let's move to another component. These are all components. So currently we are talking about all the different VPC components. Okay. The next component in the list is route table and routes. So what is the route table? And first of all, what is the route? So this route means it is a network route. So how, inside, suppose you have created one VPC, guys. You have created the subnet. You have created the VPC. So now, how, suppose, inside your public subnet, there are two type of subnets, public and private. I'm going to tell you what the difference when we will in the coming slide. But suppose inside a public subnet, you have created a web server for your application. Now, how your customer is going to access that web server inside your VPC? How it is done? So that will be done through a network route. So one route will be created, and inside that route, that will be a public route. So with that route only, the customer traffic is going to hit your web server. So suppose today I'm trying to access, Amazon.com and want some details from Amazon.com. So what is going to happen? They would have created their application inside VPC, single VPC or multiple VPCs, and then whenever I'm going to search for some kind of a product on the Amazon.com, then my request will flow through the network traffic which I have specified inside the VPC. So it's going to hit the web server of Amazon.com, and then I'm going to get the response. So how the network will flow inside a particular VPC is defined under the network rules, and where you will where you will put these network rules, you're going to put these network rules inside a route table. We are going to create a route table which is going to contain a set of rules or routes that you can configure to direct traffic from your subnet. Definitely, the traffic will first reach to the subnet. Inside subnet only you have launch your web server. So this route table contains all the network traffic routes, and these traffic routes it will define a route that how the traffic is going to flow inside your VPC. Okay. So a route table contains a set of rules. These set of rules are also known as routes or routes that you can configure to direct traffic from your subnet. Okay. Each route specifies a destination and target. So whenever we are going to create a route table, inside the route table there are two components. One is your destination, other one is your target. So destination will be your IP address. Okay, where the network will be set, and the target will be a local or other kind of a targets are there, which we are going to learn in coming slides. So suppose here this is a local target. So whenever you are going to create any route table, so by default a route table is going to contain one local route, and this local route is used for VPC's local communication. So how the traffic is flowing inside the VPC is taken care by this local route. So by default, whenever you're going to create a route table, this route will be present as a local route, and you should not delete this local route, because if you're deleting the local route, it is going to disturb the routing of your VPC. So you will get this by default. Every route table will contain a local route for communication within the VPC. So it will contain two things: target and destination. This is how the local route is going to look. So whenever you're going to create a VPC, you're going to find the similar kind of info. Okay, and each subnet must be associated with a route table. So whenever we create the route table, we are going to attach subnets to each route table. So a single subnet is attached to a single route table, and a single route table can have multiple subnets attached to it. You understand? For each subnet should be attached to a single route table. Suppose I have created 4 route table, and suppose I have attached subnet 1 to route table 1, then that subnet cannot be attached to another route table. But that route table 1 can also attach another subnet. So multiple subnets can be attached to a route table, but a single subnet can only be attached to a single route table. Okay, so this is a route table. So we will create the route table. Inside that we have to define the route, and this is going to control the this is going to define the flow of the network inside your VPC. Okay, so this is the route table and routes. So let's take the key takeaways of this section. First of all, we have discussed VPC, which is an logical isolated section of AWS cloud. Inside that you can create your own AWS resources, and you can define your own virtual network. And then a VPC belongs to one region. I told you it is a one region and requires a CIDR block. So CIDR block is for both your VPC and subnet. So please don't get confused, okay, between CIDR and subnet. And a VPC is divided into subnets. So when you're dividing a VPC into a smaller network, all each smaller network is known as subnet, or you can also remember the subnet as a subset of your VPC. A subnet belongs to one availability zone and requires a CIDR. Definitely CIDR is required for subnet as well, and you can create subnet inside a single availability zone. Route tables control traffic for your subnet. Definitely, with the help of route table, we are going to define the routes, and with the help of that route only, the network is going to flow. So that's how it is going to control the traffic where the traffic is going to be flow will be defined inside the route table. Okay. Now route table has built-in local route. So I told you by default, whenever you're going to create a route table, that time you're going to get a local route. And inside that local route, it will contain the destination target for a local route, and that local route helps you for the local communication inside the VPC. You add additional routes to the table. Apart from local route, you can add the additional route to the table for your network control. The local route cannot be deleted. Actually, it cannot be deleted, because if it's getting deleted, then it is going to hamper the performance of your network flow inside the VPC. So this was about the section 2. Let's move to the section 3 of this networking goals, that is your VPC networking. Now we're going to see the networking components of your VPC. So let's check out. So the first one is your internet gateway. As the name says, it is an internet gateway which provides internet to your VPC. So now what happens, whenever suppose, you have created your application, and you have deployed that application inside your VPC. Now definitely you need some gateway. From there your customer traffic is going to enter your VPC. So that gateway is your internet gateway. So from here all the internet traffic is going to enter your VPC. So this internet traffic is a public traffic. So suppose in future if you want to update your machine, like inside the public subnet, you have like inside the public subnet, if you want to upgrade your web server, then how can you do? You need some internet. So how you will get the internet from the outside? Because VPC is a private cloud, virtual private cloud. So how you will get the internet to your web server? It will be done with the help of internet gateway. Internet gateway is a starting point of your VPC. From here the internet is going to flow. From here all the customer is going to enter your VPC. It is a gateway to your VPC. So if you will consider like at your house, so every house is having a main gate from where the people will enter and they are going to exit. So same way you can consider a gate for a VPC, and that gate, the main gate is internet gateway. From here, once that once the gate is open, the network will flow inside. Okay, the internet, the customer traffic is going to flow inside, is going to reach your application. Okay, so now look at how it is connected now. Okay, so we are going to connect internet gateway to our public subnets. So now here I will tell you the difference between public and private subnets. So what are public subnets? Public subnets are those on which you will connect your internet gateway. So the subnets where internet gateway is connected is known as public subnets, because these public subnets, the servers inside the public subnets are directly reachable to the internet. Okay, and what are private subnets? Which are not directly attached to the internet gateway. So here the direct internet traffic would be coming to the private subnet, or I would say customers cannot directly reach out to the private subnet. That's why that's a difference. And ideally inside the private subnet we create our databases. We create our database servers where our database is hosted. And inside the public subnet we create our web servers or application servers. Okay, but we never create database servers inside the public subnet, because these public subnets are directly reachable by customer. Because how it is reachable? Because internet gateway is directly attached to the public subnet, and we do not attach internet gateway to the private subnet, so that our database will be secure. Because database is a very integral part of your application, so you don't want anyone to access your database directly. That's why database won't be accessed directly through the internet gateway. Okay. So now this is the real-time example only. When you are going to create the infrastructure, that time you're going to put database in a very secure way inside the private subnet. Okay, and whenever we create a web application, we put it inside the public subnet, because through these web servers only customers going to access my application. They're going to access my application which is hosted on that web server. But I don't want them to directly access my database. That is a real-time example. Okay, so guys, now you will ask me that suppose I want to upgrade my database, then how I will get that internet facility? That can be a question. That suppose I'm not whether I'm using I'm trying to create a database server using EC2. So for that, I only have to do the patching. I only have to upgrade the database engine version like Oracle version 1 to 3, SQL version 5.8 to 6.0, like that. So how it is possible? So for that also we have another solution that I'm going to tell you in another slide, like in the coming slide. But now let's check the route table configuration of internet gateway. So I told you what is the internet gateway. It is a starting point of your application from where the internet traffic will flow through your public subnets. And now how it is connected. So look at this. This is the internet. Internet means the public traffic, the customer traffic, the other kind of a internet traffic which is required for our application. So now this internet gateway is attached to a route table. I told you that route table is used to define the network routes, how the traffic is going to flow. So you have to create a NAT gateway. So this is one of the components. You have to create a NAT gateway. Then NAT gateway will be attached to a route table. And then I also told you that we also attach public subnets to the route table. So from here we are going to attach the public subnet to a route table, and on the same route table we are going to attach the internet gateway. That means both things are attached into a single route table. That means the route is open for internet gateway to reach out to the subnet. When I'm talking about subnet, if suppose inside a subnet I'm creating 10 EC2 web servers, then all 10 EC2 web servers will have internet facility. They will get the internet directly from the internet gateway. Now check out the route table configuration. So this is one, the upper one is your local route. I told you, I will also tell you another target. Now suppose your internet, the target is internet gateway. So what is the destination? The destination is your internet IP. This is your internet IP guys. 0.0.0.0-0. This is an internet IP. It is open for everyone. Divide by 0, I told you, it is the minimum value of a network prefix. That means it is open to all. It is open to world. That's why this is the internet IP. So now, from here, the internet traffic is going to enter. What is the target? IGW is the target. So internet gateway is going to travel to your web servers. Okay. So now, is it clear what is internet gateway? How the configuration is there? We are going to, we are going to, we are going to, we are going to create this internet gateway. We are going to attach, we are going to do everything. We are going to create VPC from from end to end. So don't worry, you will experience this. Once you will do the lab, your more doubts will be clear, because once you do any hands-on, once you will do any experiment of any particular kind of a topic, the doubts will be clear. Now Mani is asking me how the public subnet server will get data from private database server. So Mani, it's not only about the infrastructure. I've told you that we are going to connect from public subnets. We are going to open some ports for those EC2, which are going to open some port for the database. So from there, data is going to travel. That is a different set of a configuration. So what happens? Currently that the data is reachable to public subnet. Suppose you have requested for t-shirts from your from Amazon.com money. So that request will go to the web server. So now how the the web server will then look for data from the private inside the database. From database, it is going to pick the 10th row. Suppose 10th row is having that particular data value which contains the name of the t-shirt, IP, the size which you are looking for, etc. etc. So it's going to pick the data from there, because we have opened the ports inside the security group. That is a different concept. Once we will go to the database section, then you are going to learn. But if you are asking me now, I'm going to tell you. So we have to open some ports at the security level, so that our instances inside the public subnet is going to connect to the database inside the private subnet. So then, with the help of this port, the data will be transferred from public subnet to private. Now, directly the customer request is not going here. It just stopped there at the web server end. From here, that particular service is calling the result from the database. So that particular port which we have opened, from there the data will be traveled back to the public subnet EC2 machine, and from here it will be traveled back to the customer. So now, the customer is not directly touching the database. Okay, Mani, is it clear? Okay. So guys, now I will tell you how, if you want to provide internet to the private subnet, then how it is possible. Okay, so let's check out that. So now there is one concept, or one VPC component known as network address translators, or known as NAT. A NAT gateway is there, which is a dynamic gateway. So you have to create a NAT gateway. Okay, and this NAT gateway helps you to provide internet to all the resources inside the private subnets without exposing them to the public traffic. Okay, you understand? This, with the help of NAT gateway, we will like all the components, all the suppose database servers. Suppose you have two database servers which are inside the private subnet. Both database server will get the internet facility, but these database servers are not exposed to internet, the internet traffic. That is the usage of NAT gateway. You can also consider it as a jump server. I would say, okay, you can also think as a jump server. Who know the jump server, they can think in that way also. So here, how to configure this NAT gateway? You understood what is the functionality of NAT gateway? NAT gateway, it provides you the internet. It provides internet to private subnets, the resources, the individual resources which you have created inside the private subnet without exposing those private subnet resources to the outer world or your public internet. So now how to configure that? So first of all, since you have to create this NAT gateway inside the public subnet. Why you have to create inside the public subnet? Because inside public subnet only we are attaching internet gateway. Ultimately, how the internet is going to come? Internet is going to come through internet gateway only. But we don't want this internet to directly go to the private subnet. So we have to travel it through a path, through some path, which is not directly exposing our database. So we have to define this NAT gateway inside the public subnet. First of all, you will create a NAT gateway. And for NAT gateway, elastic IP is important, guys. So you have to first request for one elastic IP. Once you will get that elastic IP, that elastic IP is going to attach to NAT gateway, because NAT gateway is just like a server. It's a gateway. Okay. So you have to attach an elastic IP to that NAT gateway. And then you have to create that NAT gateway inside the public subnet. So now this is complete. Now what you have to do, since I've told you this NAT gateway is going to provide internet to the private subnet, then how? Because of the route table, we have to create one in like NAT gateway route to the private subnet. So this is the private route table. So here inside the private route table, you have to create a route for NAT gateway. Look at the private route table calls. This is the NAT gateway route. So NAT gateway route is also having the destination 0.0.0 because it is also used for the same purpose. It is also giving the internet to the private subnet, to the resource of private subnet. So you have to add one private route to the route, to this private route table. That will be your NAT gateway route. So now you have attached a NAT gateway to a private route table, and inside this private route table you have also attached the private subnet. So now one route will be created. Look at this. Now how the traffic will flow. So suppose I got a request that I need to patch my Oracle database which is hosted on EC2. Since I have configured, I have to patch that. So suppose if when I am doing a patching, how I will get the internet. So internet will first come here to the internet gateway. It will go to the public route table and it will reach the NAT gateway. From NAT gateway it is going to reach out to private route table and then to the private subnet. That will be the path. So now internet is not directly touching your private subnet resources. It is going through this particular server, which is you can consider also as a jump server. We are not exposing our private subnet resources. That's why it is very, very important. Every time these are some of the components every time we use. We create the NAT gateways. We create, apart from NAT gateway, there is also a term known as NAT instance. Now, what is the difference between NAT gateway? So first of all, you have understood this NAT gateway, guys, yes or no? Then I will tell you about NAT instance. Yeah. Have you guys understood this NAT gateway? Okay. Now I will tell you what is the difference between NAT instance and NAT gateway. NAT gateways are dynamic in nature. So suppose you want to when I'm telling you dynamic, it means if suppose any kind of a network traffic is flowing through that particular NAT gateway, it is going to expand and contract according to that. It is dynamic in nature. Suppose higher width of network traffic is coming, it is going to handle that. Lower width of network traffic is pulling through this NAT gateway, it is going to handle that too. That's why it is dynamic in nature. Now, NAT instance is not dynamic in nature. It is a simple instance. It is a simple instance type. Suppose let's say T2.micro is an instance type. So it is a simple instance which is having some configuration. Since NAT gateway is dynamic and based on the traffic is going to adjust its bandwidth, its resources. But a NAT gateway is an instance which would be having a 1 VPC, 2 GB of memory like that, based on the configuration. So you will configure a NAT gateway which is a single instance. So maybe at a point of a time it can reach to its threshold. because it is having a minimum like it is having a certain kind of a AWS, like resource configuration. Like it will have a certain kind of a CPU, like 1 GB, 1 VPCU, 4 VPCU. It is going to have a certain kind of a RAM, 8 GB, 10 GB. So based on that, it is going to have a threshold. So at a point of time, suppose there are a lot of traffic is coming, okay, to the for your private subnet. That time, this net instance can fail because it can bottleneck because it is limited. It is having a threshold. NAT gateway is not having a threshold, right? That's why AWS and we also prefer to use NAT gateway instead of NAT instances, because NAT instance is a single instance. It is having some threshold of the resources. Resources I'm talking about the memory, the CPU. But NAT gateway is dynamic. It's going to adjust these resources automatically based on the traffic. So if in your question, if you are like in your exam, if any questions come that you have created your database inside your private subnet, and now you want to do patching for your database, then how it is possible to do a patching in a secure way. Then it will ask you to select two. So one thing I told you, net gateway. If I would have not told you about net instance, then you should not be knowing about net instance. Suppose in that, like in those four like options, you will find net instance and net gateway. Both are correct answer, because both are used to provide internet to your private subnet, private subnet resources without exposing them to the outer world. But suppose in case you will get one more question that currently you are using a net instance to provide internet specifically to your AWS resources at the private subnet. But that at a point you find that those updates are getting late. There is some issue in the update, and now you want a solution, like a particular VPC component that can replace this net instance, so that you will get a highly available and what do you say, like more dynamic kind of a structure. There, if you will find net gateway as a option, that is a correct answer. This kind of a question you will get, guys, on net gateway, net instance. So that's why I've also introduced to a term net instance. Both are for same purpose, but net gateways are these are, I would say, these are better as compared to net instance. And why it is better, that also I have told you. So this net gateway and net instance is clear. Let's move ahead. Okay. So now the next component under the networking is your VPC sharing. So as the name says, VPC sharing means sharing your VPC to another account. So for example, if I tell you what exactly we share in the VPC, we are going to share the subnet between different AWS accounts inside a single AWS organization. So if you want to use this VPC sharing, networking facility, then both the accounts or multiple accounts to which you want to share this VPC, a single VPC should be the part of a same AWS organization. Okay, so look at the example. There will be a owner who, suppose I am the owner. I created one VPC, guys. That VPC is inside my AWS account. Now Ashwini and Ashmita are two resources which are the part of another AWS account, which are having different AWS accounts, but we all three are the part of a single AWS organization. So now, if I want to share my subnet to Ashmita and Ashwini, that I can do, because both Ashmita and Ashwini are the part of my AWS organization. So what we are doing here, look at this. So who will be the owner of this VPC? I am the owner of the VPC, because this VPC is created in my AWS account. And what I am sharing to Ashmita and Ashwini, I am just creating one subnet and sharing it with them. So suppose already created one subnet, and that subnet I am sharing with them. And now they don't have to create another VPC. They can directly use my subnet and they can create the resources inside that subnet. Maybe the database resources, web server, whatever they want to do, they can do. So now, why, now like what is the use case of this VPC sharing? So, sometimes what happens, there are few applications, guys, in for a particular client that are highly that are interconnected to each other. So suppose there was one like there are two applications are there, different two applications are there. The first application produce some data that is the input for other application. Both are for the same client. That is highly connected because the application first is going to generate the data, and that data will be the input for the second application. And the overall both application, they create a single software. Okay, some kind of, suppose you say some kind of a supply chain kind of a stuff. So when these both are connected to each other, to have a great network connection, to transform the data within a same subnet, because inside the same subnet the network connections and the network travel will be very very high, because everything will be inside a same availability zone. So there won't be the network connections, the network travel will be very very fast, so that whenever any data is generated in this particular application, it should be reachable to application B very very rapidly, very very fast. So that's why for the use case of VPC sharing is that whenever you have any kind of a like application infrastructure where you have different applications which are interconnected to each other, okay, which are communicating to each other, which are connected to each other, and the overall this creates a single application infra. That time you use this VPC sharing. And what is the advantage of VPC sharing? First of all, you can reuse your subnet. Now account B do not have to create another VPC. They are using the same VPC in the same region. So the connection, the network connection between the applications are pretty fast. Second thing, there is no data transfer, data outbound charges. I told you data outbound charges are there in different region. Since both applications are created in the same region now, in different AWS accounts, in same region, in different AWS accounts, that means you will save some cost here, because the data outbound traffic charges won't be applicable here, because application 1 is outbounding the data to application 2 in the same region, inside the same availability zone. That's why here this is the second advantage. You are also saving some cost because there is no data outbound charges. And the first one I told you, it will increase the application performance because the network connections are very closer, and that's why the network transformation is very very fast. Now you will tell me what's the transparency here. What is the transparency? Can suppose Ashmita is telling, okay, you are the account owner, so Ashmita and Ashwin are there. They both are using having a different application. So they're telling, if I will create some component inside this subnet, and Ashmita is telling to me, and Ashwin is also creating the subnet. Whether other accounts can see others application components? No, that's a transparent. That's why there is no transparency. Whatever Ashmita is going to create as a part of this subnet inside the same VPC, that is not visible to Ashwin. Though account owner, I am the account owner, I can see that because I have the power, because I have shared my VPC. Okay, because I have the power. But other participants, because there will be one owner, other participant. I am the owner of this VPC who has provided this subnet to Ashmita and Ashwin. So Ashmita and Ashwin both are participants for this kind of a VPC sharing. So both cannot see each other's resources and both cannot see my resources. Suppose there are all over 20 servers were created inside a public subnet. 10 belongs to me, 5 belongs to Ashmita, 5 belongs to Ashwin. So Ashmita cannot see Ashwin's resources, EC2 instances, and vice versa. And same way, but I can see, I am the owner, I can see that okay, what I created, because I also have to check out the control, what they are creating, what the participants are creating in that. Though we all know we can track everything through CloudTrail. If suppose I'm doing anything wrong, everything will be tracked inside the CloudTrail. So that's why auditing is there. But owner Ashmita, here the owner is there. You can consider owner as a root, okay, because that has only given you the permission to use this public subnet or a private subnet. Okay, you are using that subnet of the VPC which is created under the owner's account. That's why he or she can check out the resources, but the participants cannot check out each other's resources. Okay, So this is how the VPC sharing is done. So VPC sharing, inside VPC sharing, we are sharing the subnets to different accounts inside a single AWS organization. And I've also explained you the how this is done, what are the advantages of VPC sharing. Okay, so let's move to another topic now, which is your VPC pairing. Now suppose, let's take a scenario, like you have created one multiple VPC architecture. Okay, so multiple VPC architecture, like you have created two VPCs. Inside a single VPC, you have launched a web server, and inside another VPC, you have launched a database server. Now, to complete the application architecture, you want your web servers to also communicate to your database server. And both database and web servers are the part of different VPCs. Now, how you can connect both VPCs so that resources inside, so that the web server, which is a part of VPC A, can connect to your database server, which is a part of database B, which is a part of VPC B. So it is possible with the help of VPC pairing. So VPC pairing, as the name says, it is used to pair two different VPCs inside a same region. Inside a same region, yeah, both are isolated to each other. Both are isolated. Both VPCs are isolated to each other. Ashmita. Okay, so we have connected those for the communication. Okay, so we create this for creating a like a very highly available kind of a structure. Okay, which is where we are creating components inside different VPCs. Multi VPC architecture is there. Okay, so guys, here, so this VPC pairing is done to pair the AWS resources between to pair different VPCs inside the same region, or across the different region, or between different AWS accounts as well. So as this definition says, guys, you can connect VPCs in your own AWS account in the same region, and inside between AWS accounts means between different AWS accounts also, and between different AWS regions. So we all know AWS VPC is a regional service. So either you can create these multiple VPCs and you can put it and you can attach them inside a single account, single region inside a same account, or you can go or you can do this pairing between different AWS regions. Suppose your web server you have created inside Mumbai region, and database server you have created inside China region. You can attach that VPC also. Okay, that's also possible. Suppose I've created one VPC inside my account, and the other VPC is inside the Ashmita's account, like Ashmita account. I can attach that also. So that is possible only because of VPC pairing. There are some restrictions are there. IP spaces cannot overlap. IP space means the CIDR block of IP should not overlap. Suppose VPC A and VPC 3 are there. Look at this. VPC A is having a CIDR block of 10.0.0.0 divided 16, and VPC B is having a different CIDR block, that 10.3.0. This is a different VPC, different CIDR block. So you have to make sure whenever you're doing a VPC pairing, all the subnets or a VPC, a different VPC should have a different CIDR block. The IP spaces should not overlap, otherwise VPC pairing will fail. Second, transitive pairing is not supported. So first of all, I will tell you transitive pairing means non-direct pairing. So first I will tell you what is non-transitive pairing. Okay, I'll give you an example. So let's check out this. Okay, let's suppose this is VPC A, guys. Okay, this is this is VPC A is connected to VPC B, and VPC B is connected to VPC C or VPC D. Okay, how do we get? Yeah. So let's consider this as VPC A, and VPC A is connected directly to VPC B, and VPC B is directly connected to VPC D. Okay. So this is how the connection works inside AWS. This is known as direct pairing or non-transitive pairing. This is an example of non-transitive pairing. Transitive pairing. So here, this is a direct connection. Okay. So what does this mean? Suppose When I'm connecting A to B, VPC A to VPC B, that means my VPC A component can communicate to VPC B component. Suppose I've created multiple servers and I want to connect them for some purpose, for my application purpose, they can communicate with each other. Now, same way, VPC B component can communicate to VPC D components because I have a peering between VPC B and VPC D. But since like this is non-transitive peering, then VPC A components cannot directly connect to VPC D because there is no direct connection. That is the meaning of non-transitive peering. Okay, because so to establish a communication, to establish a direct communication between VPC A and VPC D, I have to exclusively create another VPC pairing between VPC A and VPC D. Then only VPC A components can connect to VPC D. This is an example of non-transitive pairing, which is supported by AWS. Now, what is transitive pairing? It is just an opposite of non-transitive. Where suppose if we are in like non-transitive, pairing environment, then what can happen? With that, with this connection only, your VPC components can connect to your VPC C through VPC B because that is non-direct peering. I'm talking about transitive, non-transitive, which is a part of AWS. Which suppose AWS, I've explained you. I'm telling you what is transitive, which is exactly opposite to non-transitive. So in the case of transitive, what's going to happen? Suppose there's a connection of VPC A directly to VPC B and VPC B is directly connected to VPC D. Now, in the case of non-transitive, a component of VPC A cannot access VPC D via VPC B. But when you're using a transitive peering, then this connection will also, permits VPC A to control or to connect directly VPC D components through VPC B. That is a transitive pairing, guys. Okay, but here the transitive pairing is not there. So non-transitive pairing is that way. Now you will understand money. Okay, non-transitive pairing is direct pairing, and this transitive pairing is indirect pairing. Let me copy this. Guys. Okay. Transitive pairing is indirect or non-direct pairing. Now you will understand money. Okay. Now this was a direct pairing. Non-transit. First of all, non-transit, which is supported by AWS. Okay. So AWS supports non-transitive pairing. So now what is non-transitive pairing? It is a direct pairing, which means when VPC A is connected to VPC B, then only components between them can communicate to each other. When VPC B is connected to VPC D, then only component between VPC B can connect to VPC D. But suppose this is VPC A, this is VPC B, and this is VPC D. So now since VPC A is connected to VPC B, they can communicate. VPC B is connected to VPC A, VPC D, they can communicate. But suppose in this non-transitive pairing, if suppose this is the connection, though VPC B is a middle point money, which also which is a middle point for your VPC A and VPC D. Then too, VPC A resources cannot access VPC D resources because this is not a direct connection. That is the meaning of non-transit bit. Non-transit. So to do a direct connection between VPC A and VPC D, we have to create a direct connection between A and D VPC. Then only you can connect. Now, non-transitive is clear, money? Yes or no? Is it clear now? Money. I think it is clear now. Yeah. Now the opposite is your transitive pairing, which is non-direct pairing. So this was a direct. Now suppose let's see the same example. This is A, this is B, and this is D. So when I am talking about transitive pairing, which is not supported AWS, it means like when A is connected to B directly and B is connected to D, then too, in the case of transitive pairing, A can also connect directly with the D VPC components through VPC B. That is the meaning of indirect or non-direct pairing. Because VPC A is not directly connected to VPC D, it is connected through VPC B. Then too, it can access because of transitive pairing. But that transitive pairing is not supported by AWS. Here we support non-transitive, that is your direct pairing. I think now both terms are clear, guys. Is it clear? Yes or no? Okay. Okay, guys. So this is one restriction is there. That means transitive pairing is not supported. Okay. This is, and the another restriction here is you can have only one peering resource between the two VPCs. So like you can have you can only have a single peering connection between, between the same VPC. You cannot have multiple peering connections inside a same VPC. So there will be a single peering connection between two VPCs. So these are the three restrictions. Now look at the route table. So how now you will say, okay, how you're going to connect. Okay, this is the thing, but how you are going to connect? So the connection will be done through the route table. I told you, inside the route table, you are going to define a route. Whatever route you are going to define, in that the network is going to flow. So what you have to do, once you will create a peering connection, it is going to provide some. It is going to a peering connection, a peering ID will be generated. So suppose let's consider this is the route table of VPC A. So inside the route table of VPC A, you have to mention the target as your peering connection. What will be the destination? So from A, we need to connect to component inside VPC B. So we have to mention the CIDR block of VPC B. Look at this. So now VPC A peering connection configuration is complete. Now same thing we have to do for VPC B because the connection will be vice versa. When A is connected to B directly, A can connect to B and B can also access the A component. So in the same way, you have to make the modification inside the route table of VPC-B. So inside the B route table, VPC route table, you have to, under target, you have to mention the same peering connection which you have mentioned here in the VPC-A route table. But now the destination will be of VPC-A because what will be the destination for VPC-B? For VPC-B, you have to connect. You have the components of VPC-B need to be communicated to the VPC-A. So here you have to provide the IP of VPC-A. Once you will complete the configuration, that means that means your configuration is complete, and you will be able to communicate the resources. Then the resources can communicate with each other inside both VPCs. I hope it is now clear how it is placed. You have to mention the routes inside the route table. That will be your peering connection route. For route VPC A, you have to mention the VPC B destination, and for VPC B, you have to mention the VPC A destination, so that the communication between both VPCs will be vice versa. Okay. So I hope this VPC peering is is done. Okay. I think you have mm, so you understood the VPC pairing. Durga, it is a type of connection. Okay. When if suppose how you can connect multiple VPCs, you can done that is that's a theory like transitive pairing. The way to connect the VPCs with the help of this transitive and non-transitive pairing, you can connect the VPC in some structure. How the what is the structure of VPC pairing that is defined under transitive and non-transitive pairing. In transitive, it's like in transitive pairing, we can non-directly connect VPCs, but inside the non-transitive pairing, which is supported by AWS, there you have to directly connect everything. Okay, so that means how you're connecting, how the structure of your VPC connecting is defined under the non-transitive or transitive pairing. Now, so transitive pairing, Asha, I've already told you, okay, let me just quickly revise and you have to go for break. So transitive pairing is a non-direct pairing. So we'll see the example this, okay. Let's check out our example. Here A is connected to B, VPC A is connected to B, and B VPC is connected to VPC D. So since this is a non-direct pairing, transitive pairing, so the resources of VPC A can also connect to VPC D resources through VPC B. That is possible. In inside the transitive pairing, which is a non-direct pairing. How it is non-direct? Because VPC A is not directly connected to VPC D. Then through VPC B, they can access each other resources. But that is not possible in AWS. In AWS, it supports non-transitive pairing, which means direct pairing. So for VPC A to directly connect to VPC D resources, there should be a pairing connection between both VPC A and VPC D. I think answer is it clear? I have repeated one more time. Yes or no? Please respond. We have to go for break then. Okay. Okay, guys. So it is done. So let's go for a break, guys. It's already 10 minutes to 8, 10, 8, 11. Let's meet after 5 minutes, okay? Then we're going to start with another topic that is AWS site-to-site VPN. Okay, guys, I'll see you in 5 minutes. Thank you. Hello everyone, welcome back. So, Durga, you were asking based on our requirement we can choose. No, there is no choice, Durga. It is not supporting transitive pairing. So only non-transitive pairing is there. So there is no fact of choice. Okay, you will just create a VPC and suppose if you are having a multiple VPC infrastructure and you want to connect two VPCs, then simply you have to create a pairing connection, direct pairing connection. That is the thing. Only to differentiate between what is transitive and non-transitive pairing, I have explained you both parts that you should know what is transitive and non-transitive. In AWS, transitive pairing is not supported. Okay. Mhm. Yes, yes. If you want to, yeah, then you have to update the route table if you want to connect VPC-A directly to VPC-C. Yes, Raghavan. Okay, guys. So now the next topic is AWS site-to-site VPN. So this is also one of the networking component. So till now, this VPC sharing or VPC pairing, what we were doing, we were connecting different VPCs inside AWS region. That was native AWS infra. If suppose your whole infra is created only on AWS, then you can use those stuff. VPC pairing or VPC sharing. Okay. But suppose if you're using a hybrid model, like hybrid cloud model, where some AWS, some infra is created on-premise server. Okay, and then some part of the infra is created on AWS VPC. Now, how you can connect your AWS VPC to your on-premises data centers? It is possible through AWS site-to-site VPN because this helps you to create a hybrid cloud model. So suppose if you want to connect, so VPC is a virtual private network, which is a connection. It is a tunnel connection. There's a tunnel. It is a two-way tunnel, guys. So like there are two tunnels which are created, which are very secure tunnel. This whole tunnel is encrypted with advanced encryption system 256 bits. This tunnel is a VPC tunnel, which is connected. Suppose this is our AWS VPC, which is having our resources, and we are creating a hybrid model. We are suppose our database is on, like our application and web server we are created on AWS VPC, and like inside the corporate data center, your on-premise data center, we have a database server. Okay, so now we have to connect the whole infra to for the application purpose. So for connecting this hybrid model, we use this side-to-side VPN, which is a virtual private network, which is a tunnel. So one tunnel will be created. Okay, our tunnel will be created, which is a which is a highly secure tunnel, because this tunnel is encrypted. So whatever data will be flowed, vice versa, will be encrypted. So in between, nobody can hack your data. And moreover, this tunnel is highly available, guys. How it is highly available? Because when you will establish a VPN site-to-site VPN connection between AWS and your on-premises infrastructure to connect the hybrid model, that time it is going to create two VPN tunnel for you. First one will be the primary tunnel, second will be a secondary tunnel. So suppose if the primary tunnel went down, then automatically secondary tunnel will come into the action. It is going to communicate the data between the on-premises and your AWS. So it is highly available solution, which by default creates a two tunnel. First will be the primary tunnel and second will be the secondary tunnel. So secondary tunnel will be idle till the time primary tunnel is in action. So suppose suppose if there is any disruption happened in the primary tunnel, and if the connection went down, so the secondary tunnel is going to take over. That is going to help to flow the communication, so that your communication won't break. Your communication won't break. Yes, it is a virtual private network. That's why we are doing it, a virtual private network. So now you guys, you come to know what is VPN. VPN is a virtual private network where we create, where we connect our AWS VPC to on-premises infrastructure. Okay, to create a hybrid cloud model. And basically in VPN we create a highly secure tunnel with advanced encryption technique of 250 bits, and this VPN is highly available. And what is the kind of a maximum speed we will get? We will get up to 2.5 Gbps. That is the highest speed. So whenever you are connecting to VPN, the data will be transferred with a maximum speed of 2.5 Gbps. That is the speed threshold. Okay, and it is a secure tunnel. It is having two tunnels integrated. First will be a primary tunnel. Second will be a secondary tunnel. Initially, all the communication will go to the primary tunnel. Second tunnel will be idle. Once there is any issue in the primary tunnel, once there is any breakout in the primary tunnel, then automatically secondary tunnel will work as a primary tunnel. Is going to travel your data securely through this VPN channel. Okay, so that's how you are securely, like privately, you are connecting your VPC to your corporate data center. Okay, that's the use of side-to-side VPN. Now, how to configure that, guys? So first of all, there is one term known as virtual gateway. So internet gateway was there when you want to access directly to internet, from internet to when internet want to directly access your AWS sources. Now for connecting your VPN, first you have to create the virtual gateway. So virtual gateway is also one of the component which is used for this hybrid model. So you have to create one virtual gateway, and from here, then you have to create one VPN connection. So one VPN is also component. Just create the VPN connection. Then you have to connect your virtual gateway to VPN. So till here you have completed the AWS part. So till here the AWS configuration is completed. Now your AWS VPC is connected to VPN through virtual gateway. Now the second part, which is your customer part. So customer will also have one customer gateway. One hardware will be there, which is known as customer gateway, or you can see a big router will be there. So where you will directly connect your VPN. So now the channel will be completed. So all the traffic which is flowed from it, suppose we are flowing, like some request came to, web server which is hosted inside the AWS, like AWS VPC. So request will first flow come to AWS. Now suppose it needs some data from database to project it on the user's screen. So the request will flow through virtual gateway to VPN to customer gateway to your corporate data center, and then the same way vice versa the flow will be there. So that's how the whole channel will be complete. Now let's check out the route table. Now look at the route table. Okay, since we are connecting the private subnet here to the corporate data center, here we have to provide a target of virtual gateway. Virtual gateway will be the target and this will be the destination. What destination? Where we have to send the data? Send the data to corporate data center. So you have to get the IP of the server which is inside the corporate data center, which you have to make here. So with the help of side-to-side VPN, we create a hybrid model where you want to connect your VPC to on-premises servers. So that is the use of side-to-side VPN. It is highly secure, having AES advanced encryption technique system of 250 bits, and then too it is highly available because it uses two tunnels. One is primary and second is secondary. And third point is there, the maximum data transmission speed is, network speed is 2.5 Gbps. Okay. Okay, guys. Yeah, both are different. Ashmita, internet gateway is to provide internet to your AWS, AWS VPC, your server inside the AWS VPC. But when you're using virtual gateway is to, it is used to create, it is helpful for creating the hybrid connection. So if you want to connect your, VPN, you can connect through virtual gateway. Okay. Since it is accessing private, yeah, they have not mentioned. We will definitely use Shrikant. That's a good thing you have recognized. You can create a net gateway here. Yeah? They are just giving you a demonstration of VPN. That's why they have not projected net gateway here. But you should always use net gateway to access your private servers. Okay, that is correct. That should be used as a part of creating a good infrastructure, good AWS infrastructure. Okay, so the side-to-side is clear, guys. Now let's move to another component known as AWS Direct Connect. Now the Direct Connect is also, this also solves the same purpose to create a hybrid model. So for example, if you want to have a high-speed, hybrid model where you want to connect your AWS VPC to on-premises servers, to your corporate data center servers, then if you want the connection which is more secure and more speedy, like the network speed is very high, then you should choose this AWS direct connection, because here they're using the private lines. All the communication is going through the private VLANs. It is a virtual LAN system. You know what is LAN? Local area network. In local area network, we use this local wires and all to create the connection. Same way, they have created virtual LANs. So the connection, that connection is through the virtual LANs. So these virtual LANs are more secure as compared to VPN. Though VPN is secure, but if I'm talking about more secure, then you go for AWS Direct Connect. The second point I told you, speed is pretty much high. Yes, the data which will be traveling through this VLAN will have a higher speed of around 10 Gbps. And in AWS side-to-side VPN, what was the highest speed? 2.5 Gbps. Here the highest speed is 10 Gbps, around 4 times higher as compared to VPN. So these are a bit costly. Like when you're doing that connect, you have to pay some more amount as compared to setting up a side-to-side VPN. So now so it is solving the same purpose, guys. I've told you the difference between VPN and Direct Connect. There are two differences. First one is Direct Connect is more secure because here the data is flowing through the private VLANs. Okay, private lines. That's it is connecting your VPC to on-premises data center. So that's why the connection is consistent. Suppose if you want a consistent speed of 10 Gbps, you will get it through Direct Connect because it is a private connection, more secure connection, highly speed connection. So when it is helpful, suppose you are having a streaming application, you have created a hybrid model and you are projecting a streaming application like YouTube. You are having an application there. You want data to be streamed at a smoother network rate. Suppose so for that, using this AWS Direct connection, the speed will be smooth because the connection is smooth. The connection is privately connected and there are no roadblocks in between, and the streaming will be smooth because it is having a continuous flow of data packets at a particular bandwidth. Okay, that is of direct connect. So now how to connect the direct connect? The same way, virtual gateway is also required here. So virtual gateway is going to send through a VLAN. So you have to also configure one AWS Direct Connect service from AWS, and then you have to connect your virtual gateway to AWS Direct Connect, and then AWS Direct Connect is going to connect the customer data center through customer gateway. So just we are replacing here what we were using, guys. In the previous example, we were using site-to-site VPN, and here we are using direct gateway. All the other components are same. Only this thing we have just changed. Okay, both things, but both solve the same purpose. Both are used to create a hybrid cloud environment where you can also use your existing on-premises servers, and you can also take the advantage of AWS VPC or the AWS infrastructure. The difference I have told you, the speeds are different, and the second difference is your security is a difference, because direct connects are private lines. Okay, and these are more secure compared to VPN. This is the difference, guys. Okay. Yes, you have to work out that money. You have to revise that, then you can remember. Revise daily. You will remember. Don't be afraid. I'm explaining you the things in a very, very simple way. Just revise daily, and it will be there in your mind forever. Don't mug up anything. Just revise daily. Whatever I'm telling you, whatever I'm teaching you today, please revise on the same day. It will be in your mind for a longer period of time. Don't worry. Don't mug up anything. Just understand the concept. Okay. Things will be there. There will be more things visually coming into the plate. Okay. It's more advanced topics will be there. Okay. So guys, now understood what is direct connect, what is site-to-site VPN. Is it clear, guys? So now let's move to another topic. Okay. So now the another topic is VPC endpoint. So this is one of the networking component of VPC, where suppose there are few services which we cannot define inside the VPC, like S3 or DynamoDB is there, which you cannot define inside the VPC. Now suppose, let me take an example of Instagram app. Okay, suppose you have created one, Ashwini has created one social media app, and Ashwini is using AWS Infra. So Ashwini has created one VPC. Inside that, he has launched one AWS, server. Okay, like inside the subnet. Now, on that server, a web server application is hosted. Now that whenever anybody is uploading a video or a video file, MP3 file, or pictures, that is internally getting saved to the S3 bucket. But we cannot define S3 bucket inside VPC because that is not possible. Some components we cannot define. So how we can connect this S3 to the EC2 server, which is inside the AWS? So VPC endpoints helps us to connect AWS VPC components to other AWS components which are out there, which are outside, which are created outside of your AWS VPC. So look at this, the same example. Suppose we want to connect, this particular instance inside this private subnet to your S3 bucket. Then it can be done with the help of VPC endpoint. So now VPC endpoints are of two types, guys. First one is your interface endpoint. So this is an example of interface endpoint, guys. So interface endpoint uses a private IP, using elastic network interface. So with this endpoint, it will use a elastic network interface, and with the help of that private IP, you're going to connect it through the outer world service. Okay, that is your S3. Actually, okay. So I'll repeat the definition once again. VPC endpoints are used to connect your AWS VPC resources to other AWS resources which are outside your VPC. Okay. So like any service means, like all these S3 is a service. S3, no, not only S3, there are multiple services, Asmita. Please wait, okay, let me explain both types, you will come to know automatically. Okay. So first one, suppose this is an example of, since in the example we have used S3, apart from S3, you can connect multiple services through these endpoint types. So first one is an interface endpoint which uses private link. So private link is a private connection through ENI. So it uses ENI. From here you can connect this particular server which is inside the private subnet to your S3 bucket. That is the use of interface endpoint, which uses AWS private link using ENI. So interface endpoint supports multiple AWS services. Multiple AWS services, like there are, like Lambda, Cloud Commit is there, Code Pipeline is there, there are, like when you will search for this interface endpoint, you will inside the documentation, you will come to the page where you will see what all kind of services are there, this AWS services which are supported by interface endpoint. So with the help of the interface endpoint, you can connect all those services to your AWS VPC resources. Okay, so it supports multiple services, more than 30 services they can support. Now, come to the second type of endpoint, that is your gateway endpoint. So gateway endpoint, it is a type of endpoint which only supports two services, S3 and DynamoDB. When you are creating a VPC endpoint as a gateway endpoint type, then you can only connect S3 or DynamoDB using this gateway endpoint. If you want to connect other services like Lambda, Code Build, like some kind of a big data services, that you can connect to the interface endpoint. Now for gateway endpoint, you have to define the route. For example, look at this route table. Since it is not using ENI, gateway endpoint does not use ENI for the private connection. Instead of that, you can directly open the route table of your, like AWS VPC. Inside that, you have to define the VPC endpoint ID. Once you create the endpoint, it will contain a VPC endpoint ID and then just provide the destination. So in this example, if you want to connect a server or server inside the VPC to Amazon S3 service through gateway endpoint, then we have to modify the route table of VPC and then look at this. This is the target will be the VPC ID, and what is the destination? Destination will be your S3 ID. What is the S3 ID? S3 ID means ARN. I told you what is ARN? Amazon resource number. That is the ID of each resource that you have to mention here as a destination, because in this case, suppose if you want to connect DynamoDB, same thing, you can put it under the sub route table, the ID of your DynamoDB, the ARN of your DynamoDB. But only with the help of gateway endpoint, you can only connect two services, S3 and DynamoDB. That is the limitation of gateway endpoint. Apart from that, interface endpoint, with the help of internet endpoint, you can connect almost 30 plus services. So you can search out the documentation, you will get a list of different services. Nobody is going to ask you, how you can simplify. You can simplify the running. Suppose if you get a question that you want to connect, S3 which is outside your VPC to your, EC2 instance running inside the public subnet. How you can connect? You see gateway endpoint, click a trick, just take it off. If you find some other service, suppose you want to connect AWS Kinesis service to your AWS VPC, then that is possible through interface endpoint. So just learn that gateway supports only these two. Apart from that, all can be connected through interface. That's how you can simply remember the things. Okay. So now, is it clear what is the use of a VPC endpoint? What are the two types of VPC endpoint? Interface and gateway. Gateway only supports S3 and DynamoDB table. For gateway, you have to modify the route table, and for interface, there's a requirement of ENI. So once you will create the interface endpoint, it's going to automatically create a ENI. With the help of that, you can connect your outside resources to your AWS. That is the thing. Yeah, DynamoDB is a service, Nitin. DynamoDB is a database service. DynamoDB is a database service. They are going to learn this service in the database section. Okay. Okay, guys, let's move to another component known as AWS Transit Gateway. Now, what is the Transit Gateway? Transit Gateway is a, like most versatile service, okay, out of this. With the help of this Transit Gateway, no direct. Sorry, what no direct connection is? I'm not getting it. What kind of direct connection? This is a direct connection. Inside endpoint, we have a direct connection only. Okay. Now, what is Transit Gateway? Transit Gateway is a central platform from where you can connect multiple VPCs. You can connect your VPC to your corporate data center. You can also connect your VPCs, like both. You can connect different VPCs using Transit Gateway. You can also connect, VPC to your corporate data center using the same Transit Gateway device. If you will see this left side diagram, look at this. so much confusion is there. Here you are using hybrid model also. Suppose like you are connecting your VPC, you are having through VPC pairing, you are connecting two VPCs. You are also using VPC VPN connection to connect your VPC to your customer gateway. Like that, you are also using a direct connect gateway, direct connect to connect your VPC to your like your customer gateway. So when the like in starting, it seems to be simple when you are having a little infra. As your application will grow, you may be using multiple VPCs to host different kind of a application component. You may be using a hybrid model also. That time there will be a lot of mix up in the infra. So to simplify that, to convert this whole mix up of an infra into a simple way, we have a single AWS component known as AWS Transit Gateway. With the help of a single component, you can connect multiple VPCs in the same region, in different region, in another account. Apart from that, you can also connect VPC to a on-premises on-premises data center as well. So this transit gateway uses a hub and spike model. So I'll give you an example of this bicycle tire. In bicycle tire, if you would have remember, if you will see the bicycle tire, it is having one hub and multiple spokes are there that connects the tire. So that hub is a transit gateway, and those multiple spikes are your different components like AWS VPCs and AWS Direct Connect, etc. etc. So it follows a hub and spoke model where hub, the center part is your transit gateway. So all the requests, maybe if you want to connect to VPC, the request from VPC A will be flowed through the center VPC B. Will be flowed through the transit gateway, which is a hub, to the another spoke, that is your VPC B. Same way, if you want to connect VPC to a particular data center, on-premise data center, then the traffic will flow through the hub, that is the center point. That's why it follows the hub and spoke model. Okay, and hub is your center part, which is your transit gateway, and VPC and other data centers, on-premise data center are all spokes part. So for connecting anything, the request will go through transit gateway, which is a center part. Now is it clear? That's why AWS transit gateway is very very useful. Though it is a bit on a higher side when it comes to pricing, you have to pay a bit more because this solves a lot of issue. Look at this. This infra was very difficult to understand because look at the connection, how the connection you have to consider. But now the same thing is simplified with the help of transit gateway because it's a single component which is replacing your direct connect, your VPC pairing, your VPN connection. With a single component, you can achieve this kind of infra. That's why it is very helpful, guys. And you can also connect multiple transit gateway. You can also connect one transit gateway to another transit gateway, and you can connect more than 1,000 VPCs. I think more than 1,000 or around 5,000. Okay, I think more than 1,000 VPCs you can connect using your transit gateway. So that's why this transit gateway is powerful. Now you know it follows hub and spoke model, and it is a center part from where the request will flow through the center part only, whether you want to connect to VPCs, whether you want to connect VPC to your on-premises infrastructure. So replacing all the multiple connections to a very simplified way. So there is the meaning of AWS transit gateway. Hub and spoke model. Spoke, SPOKE. Hub and spoke model. Just connect everything with a real examples, guys. You will have a better understanding, and that will remain in your mind for a longer period of time. I've given you an example of I've given you an example of what do you say? Like I've given you an example of this bicycle tire. That is an example of hub and spoke model. The tire looks like a hub and spoke. The central part is hub. Consider it as a transit gateway, and all the spokes are different connections of VPC and different VPC than your and on-premises things and all. In Instagram public accounts and private accounts, how it works, sir? What is, I'm not getting you. In Instagram public account and private, that is not a part of this networking account. That's a different configuration. That like they have created different things like public accounts and private accounts and different stuff. That is handled with the help of code money. They are writing a code. Some things you will handle through code also. When you're using Instagram, you say asking, we create public accounts, we create private accounts. That is the application configuration that we are not handling through the infrastructure part. That is a part of application configuration. If suppose when you are clicking on something and making a public account to private, that is the code we are writing for that particular application. So that things will be handled through the application logic, application code, not through the infrastructure part. Okay, Mani? Okay, guys. So same thing I'm telling you, it is, whenever you're telling that you're writing the code and based on that, they are blocking the things, okay? They will block the access over there and your data will be saved on the same layer, but they are going to, block it. So with code also, suppose, with code, okay, I'll give you a simple example. Suppose you've created a simple form. Let's go very simply. When you have created one, form, okay, a form kind of application where you have to fill your, mobile number, suppose. So we all know mobile number is of 10 digit. So I've created some code logic, okay. Suppose if I am writing there 11 digit, then it won't accept that. So something we are going to handle it through code. That's how the logic is built. Okay. Okay, guys. So this transit gateway is now clear to you guys. So yeah. So now let's check out your understanding on these topics. Now we're going to label this network diagram. I'm going to just hover my mouse. You're going to tell me what are this kind of a resources. So what is this, guys? I'm hovering my mouse here. What is this inside the VPC? What is this particular stuff? Now tell me. Till now you have seen Q infra. Now it's the time to yeah. Very good, guys. This is a region. Now what is this? The green layer. Now what is the green layer? Very good. This is VPC. Now what is this? I'm moving here. Very good, Srikanth. What about others? Yeah. This is a particular availability zone. Okay, now tell me what is this? Okay, what is this? The whole stuff. Very good. This is a route table. Now inside the route table, I am pointing to the first one. What is this? The first row. Yes, very good. It is a, yes, it is an internal route. You can say it is a route. It is a route. Very good. Now under the destination, what we have to fill here? For a local route, what will be the destination? I told you. For a local route, what will be the destination? IP address is here. Which IP address? The IP addresses are mentioned here. Tell me the IP address. The CIDR block. The CIDR block, tell me which CIDR block will be here for local communication. Very good, Raghavendra. I got a correct answer from Raghavendra only till now. This question. This local route is for VPC. Then definitely it will contain VPC CIDR. What is the VPC CIDR? 10.0.0.0 slash 16. Yeah. Not 24. Plus 24 is your subnet. I told you this block at the VPC. Local route is for internal VPC communication. So it will be a VPC CIDR block, Srikanth. Okay, guys. So now let me move to, okay. Now tell me the target here. What will we target for this? Consider this as a public route table. Now tell me what will be the, this is a public route table, guys. So what will be the target here for this public traffic? Very good. Very good. Chinna, this is whatever you mentioned, Chinna. That's the destination. I'm asking the target for the destination. Consider this as a public route table. So what it will be? Yes, it will be the internet gateway. So there will be an IGW ID. That will be internet gateway ID, which will be the part of the target for public route table. Okay. Now let's move to inside the VPC. Now what is this component? What is this component, guys? Very good. This is a, no, this is not a server. This is a internet gateway. Look at the connection. You guys check the connection also, na? So internet is going through, I told you how the internet, what is the starting point of internet in your VPC? What is the starting point? Is the internet gateway. So internet will be coming first to internet gateway. Now how it will be moved here? What is this? This is your, what is this? Very good money. Very good. This is your route table, guys. Now, look, now come inside the, now comes here. What is this? No, I'm not. Yeah, very good. Very good, Srikanth. This is your public subnet. This is your public subnet. Now, what is this device? Very good. This is your net gateway. Now, how we come to know this is a public subnet? We know net gateway we define as the public subnet only. Now, what is this? Yeah, it can be public IP or private IP of this particular EC2 machine. This is a EC2 machine and it will be having the public or private IP. You can tell anything, public or private IP. Okay, now let's come back to another subnet. What is this subnet? This is another subnet. Yes, this is a private subnet. Now, what is this bus kind of a structure, guys? What is that? I told you. What is this? Very good. Shanna. Very good. Not EC2, Vishnu. This is elastic interface. Elastic network interface. This is ENI. Okay, what ENI provides us? What is this? Very good, Srikanth. This is a private IP. Okay, so yeah, we have completed all the components. I am very happy that you guys can now recognize the different component of infra. Because you know what will happen when you will start working as a cloud engineer. Sometimes you will get a chance to work, from the scratch, starting position. But there can be certain, conditions where already the infra has been created, and to understand the structure, you have to check out the infra. So that time you will get the diagram and you will understand with the help of these. When you know the component, then only you will be able to understand how the connection is flowed. Okay, which components are used for what purpose. You will come in. Okay, here we are defining net gateway. This will be the public subnet, and how the connection is for net gateway is through the route table. So based on that, okay, you're going to understand the different infra built with AWS. Okay, built on the AWS part. Okay, this is the solution, guys. You have answered everything correct. Look at this region is there, availability zone, VPC, public subnet, public or private IP, net gateway, internet gateway, route table. This is also your route table. This is a particular route. This is a particular route, and this is your IGW because we are considering it as a public route table. This is your elastic network interface having private IP. So this is the complete thing which you have already answered correctly. Very good. So this brings us to end of your ENI provides internet. No money. No. ENI never provides internet. I have told you ENI is used to provide a private IP to your servers. So how, I told you on private IP, it will take it from the subnet CIDI block. It is going to attach it to your instance. That's how the private IP gets attached to your instance using ENI. That is the functionality of ENI, the first topic which we have learned today. Now remember, is it clear? Okay guys, so this activity is completed. Let's move to, let's see this recorded demo. Okay, so for VPC creation, so this is a basic demo. We are also having a lab here, so we're going to complete the lab once we will reach out to this section. Okay, so let's just check out, okay, this recorded demo, how to create a VPC. So first you have to log into your, how to set up a demo for this, how to set up virtual private cloud. So to log into management console, from here you can search for VPC. You can either search for VPC here, or you can come to the network, service section, and then you can search for the VPC service. And make sure that you have to create the VPC. Wherever you're creating a VPC, inside that only inside the same region, you're going to create the EC2 machine and going to launch those machines inside the same VPC, because VPC is a regional service. That's all. Okay, so if you make sure your components and VPC are in the same region. So come down and under your network and content delivery, you will find the VPC service. Just click on here. Okay, so you'll be now navigated to the VPC console. So you can do either you can just click on your your VPCs from here also, from this left hand menu, under your VPC also you can check out all the number of VPCs which you created will be present here, or a default VPC I was talking about, that will be here. And from here also you can create another VPCs. And for very simple part, you can click on start VPC wizard. From here also you can start creating a VPC. So in this example we are using start VPC wizard. So now with the help of VPC wizard you can create four type of VPCs. VPC with a single public subnet, VPC with public and private subnet, VPC with public and private subnet with along with VPN access, and VPC with a private subnet only and hardware VPN access. So we are going to use VPC with public and private subnet. That is a used in most kind of a configuration. We'll click it over here. Now we are going to define. Okay, so here just see just explaining, okay, the same stuff. What are the different kind of a VPC, the full kind of a VPCs we can create, different kind of VPCs we can create using the VPC wizard. Okay, so now we are going to select VPC with public subnet. So now click on select over here. Okay, so we just click on select, and now we will be navigated to the VPC configuration page. So first of all, we have to provide the CADI block of a VPC. So currently it is using 10.0.0.0 divided by 16, which will give us roughly 65531 IPs to be used, because 5 IPs are taken by AWS. Now look at this. You have to provide the VPC name over here. If you are going to provide a VPC name, you can put anything like demo VPC or any VPC, some kind of a meaningful name you can provide. And look at this. Currently we are not using the IPv6 CADI block, but it also supports the IPv6 CADI block as well. But we are going to work on IPv4 only. So he is giving name as demo VPC. Now he is adding the public subnet. So this is the CADI block of public subnet. So look at this. I have told you every time the CADI block of subnets will be smaller as compared to the CADI block of the VPC, because subnets are subset. So here we are using a divide by 16, a largest CADI block, but here we are using divide by 24, which is a smaller CADI block. So look at this. Here we are getting 251 IPs. Okay, so 5 IPs are used for internal communication, and where you can get 251 IPs, which can be assigned to different 251 machines. Now availability zone, you can select availability zone in which you want to launch this subnet. So I told you one subnet will be launched inside a particular availability zone. So you can select availability zone. So for this North California, we have 2 availability zones. You can use US West 1B or 1A. Now you can provide the name to a subnet. So he is giving public subnet only, I think, and now he's moving to the private subnet. Now he is going to provide the CADI block for private subnet. So look at this. This is not overlapping. This is a different 10.0.1.0. This is a different CADI block. If suppose this user is giving the same CADI block of the public subnet for this private subnet, the same CADI block, then it is going to give an error, because CADI are overlapping. So here also 251 IPs can be used, and now we have to select the availability zone. So under the availability zone, you can either select the same availability zone or a different one. So he's selecting the same availability zone, US West 1A, and then he is going to provide the name to a private subnet, that is private subnet. Now coming to the next part, that is NAT gateway. So I told you for NAT gateway, we need elastic IP. So for here he has to provide elastic IP also. But I think here he is going to use a NAT instance instead. Because here look at the use a NAT instance instead. So both options are for the same purpose. He's clicking on NAT instance. Now he's selecting the instance type. Okay, so he's selecting T1 micro, which is a very basic instance of 1 VPC and 1 GB of RAM. And then for here, okay, if you want to access this NAT instance, you can also create a key pair, because to access any instance, you need a public and private key. If suppose you want to check out, suppose you are getting some error. Okay, some internet is not accessing your private servers, and so you want to access the NAT instance, then you need this key pair. Okay, that's why it is giving a key pair option. So I think he's not going to use any key pair, because in this demo we're not accessing this NAT instance. So look at this. This is the different kind of a instance type for NAT instance, which you can select as per your requirement. Then I think he's not going to select any key pair, because he's not going to access the NAT instance for this particular demo. And coming to the next part is your service endpoint. Suppose if you want to add any kind of a service endpoint to connect your S3, DynamoDB, or other kind of services, you can create an endpoint and you can add an endpoint over here. And finally, enable DNS hostname. Yes, what is going to happen once you are going to launch like servers inside this VPC. Then apart from public IP, they will also give machine a DNS host name apart from IP. So once we are going to do the lab, you're going to learn that. Okay, I'll show you what is the DNS host name. Okay, and finally the hardware tenancy. So currently it is default. That means we are going to use a like a shared infra. So there are two types of hardware tenancy. One is default, that is your shared basis, and second is your dedicated. You all know the difference between both. I've told you like inside in the previous sessions also. So default is there inside the shared. Suppose there will be a like a single component networking component will be there where multiple customers are created the VPC on a single component, a shared basis. Suppose if you want a dedicated network component, then you have to pay more and you can use a dedicated network component, and on that particular hardware, the network hardware, only your VPC will be created. Okay, so like that. So here we'll be using a default one, and now the configuration is complete and you can just click on create VPC. So this user is going to click on create VPC, then it's going to create all these components, it's going to create the net gateway. So it will take roughly 1 or 2 minutes, and after that, once this whole process is done, then you will find your VPC will be created successfully. Then you can add the other components like net gateway, route tables, and other components which you want to be the part of your AWS VPC. Okay, so look at this. It will take some time, and once this is complete, look at this. Now it is getting completed, and now you will find the VPC is created successfully, and you can click on OK. And now look at this. Now you will find the VPC. So first one is your default VPC. Look at this. So I told you for each region, AWS has already created a default VPC. So this is the default VPC, and this is the demo VPC, which you have just now created. Look at this is a summary of a VPC. How is the VPC ID? You will get the CIDR block is there. DNS solution you have put yes. So all those details will be there for your VPC. So that's how you create VPC. So we are going to create the whole VPC. We are going to attach, internet gateway and other, route tables, your NAT gateway. We will do everything in the lab. So then you will have more confidence on this topic. So guys, let's take the key takeaways of this session. Then we're going to wrap up the session. So what we have understood here in this session, we have seen multiple networking components of VPC like internet gateway, NAT, VPC endpoint peering, VPC sharing, certified VPN, that connect and transit gateway, and you can use the VPC wizard to implement it. Then we have seen in the demo, we have used the VPC wizard. With the help of that VPC wizard, we have created the VPC, we have created that VPC. So that's it for today's session, guys. So we're going to wrap up here. I'm going to start with VPC security tomorrow. So I hope I'm going a bit slow and steady. And now I'm going to provide you the feedback form. If you have any questions, you can ask me. Okay, you can ask me in the forum, and by then you can just use this feedback form to provide the feedback to the friend. Yeah, lab will be there. Lab is there. Lab is there after some slides. I will that lab. You're talking, Chin. Are you talking about that previous lab, IAM lab, or this particular topic lab? IAM lab we're going to do it tomorrow, because today I've told you how to access that lab. So many people have not completed that lab. So we're going to wait for today, and tomorrow we're going to complete that IAM lab for sure. I've given you the feedback form. Please provide the feedback for this training, and I'll wait for another minute. If you have any question, I'm going to answer that. Otherwise, we're going to meet tomorrow. Please revise your concept. I'm going to ask you. We have done a lot of learning today. Please revise your concept. Otherwise, you will get confused. Okay. Private subnet size? No. It can be different. Depend on you. How many IPs you want to use? You can do different also. You can create more larger CIDR block for public subnet, and for a smaller CIDR for the private subnet. But for making a good infra, what we used to do, we used to create a equal subnets as a good way of creating the infra. Okay, Amina. Okay, any other question, guys? Anything else someone to answer? Okay, guys. So I think we are good with this topic. So I'm getting Ashwin signing up the canvas. So Ashwini, for this you have to connect with Sunil. He's going to help you regarding these canvas questions. You can check this Sunil. Okay. Yeah. Okay, guys. I'll see you guys tomorrow. Thank you so much for joining the session and keep revising these topics. And we'll meet tomorrow at the same time. Thank you. Have a good night. Bye.